Alright, so we found this confidence interval for the mean using the t-distribution. Now they want us to interpret that in the context of the situation. So we have to say we are 95% confident that the true average loss for pickpocket thefts, I should say, in the US is somewhere between $405.08 and $621.56. Now notice, again, I reiterate that we're not talking about a probability here. The average loss of pickpockets is a set number that exists out there in the ether, or who knows. And all you're trying to do is try to nail down where you think it is, but you don't know for sure if it's in that interval or not. All right, so what was the margin of error for this interval? Let's find it two ways. So let me remind you that we can use the formula that we've already done. So let me show this the formula way, which is the harder way, of course. That's the t alpha over 2s over the square root of n, which is this 2.06 times 2.62, right? Now the question is, what is it? Well, that's a little bit harder to manage, but remember that we used Excel in order to find those lower and upper bounds. So to get the margin of error, way number 1. Okay, so what you can do is you can take the formula that we built, put it right here, and realize that all it is it's the same formula but without that original x bar in the beginning, which is cell D4 in our example. So if you delete that and press enter, then you'll have the margin of error, which is 108.24. Okay. Now that's the formula way, but there's another way. You can do it the subtraction way. Okay. Now subtraction way, you have to keep in mind what the interval was. The interval was from 405 to 621. Okay, so remember those are the ends of the interval, and the center of the interval is the 513.32. Okay, so what you can do is you can subtract from, let's say, the high one. So take the 621 and subtract 513.32. Right? In other words, you're taking the upper bound minus the mean, the sample mean, I should say. And I will make Excel do that because that's what it's good at. So let's see, margin of error, way number 2. You can subtract. You can say, okay, take this upper bound, 621, subtract away that mean of 513. Lo and behold, it's the same number we found from up here. It's 108.24. If you have the confidence interval already made, I mean, it's really easy to do this because you just subtract. I mean, there's nothing to it. Okay. All right, so there's the other way. Now, if the confidence level was lowered, if we went to like a 90%, how would the interval change? And how would the margin of error change? So remember that if the confidence level is lower, that means that you're less certain that you caught the fish, if you will, right? So it's going to cause confidence level lowered. Causes the interval to become smaller, which means the margin of error is also smaller, because they go hand in hand. When the confidence level lowers, the margin of error goes smaller and the interval size gets smaller. It's all tied back to the graphs we drew way back at the beginning of this unit, right here. Oopsie, get back. And when you have a lower confidence level, like 95%, it's a smaller interval than when you have a 99%. So if you shrink from 95, which is what you had in your example, to 90, it's going to be even smaller. Smaller interval means smaller width, and the margin of error is the distance from the center to the edge, and that would also get smaller, right? Because they all go hand in hand. You're less certain you caught the fish because you're swimming with a bigger net, or fishing with a smaller net, excuse me.